So this is lab number 2 in solution architect series. This lab introduced to Amazon Elastic File System, which is EFS. So task 1 is creating a security group to assess your EFS file system. The security group that you associate with the mount target must allow inbound access for TCP on port 2049 for network file system. This is security group that you will now create, configure and attach to your EFS mount target. Let's go to security groups. Copy the security group ID of EFS client security group. So choose security group and security group name. In inbound NFSSS from EFS client. Let's go to create and we are going to add an inbound rule. First we need to give security group name, description, inbound NFS, access from EFS client. Virtual private cloud is going to be lab. Next is inbound rule, type is going to be NFS and source is custom. So let's create security group. So task 1 is completed. So task 2 is to creating an EFS file system. EFS file system can be mounted to multiple EC2 instances that run in different availability zones in the same region. These instances use mount targets that are created in each availability zone to mount the file system by using standard NFS v4.1 semantics. You can mount the file system on instances in only one virtual private cloud at a time. Both file system and the VPC must be in the same region. So let's go to create file system. In create file system, we will choose customize, uncheck enable automatic backup, life cycle management for transition into IES select none, in tags option, key is going to be name, value is my first EFS file system. Choose next. Lab VPC. So detach the default security group from each availability zone. Okay. Attach EFS mount target security group to each availability zone. Let's create. So it says is not authorized to perform elastic file system. Put file cycle configuration on specified resource. Hmm. So we have created a new file system. Task 3 is to connecting to your EC2 instance. And choose AWS details and copy the value for instance session URL. So let's open a new window. Paste it. Task 4 is creating a new directory and mounting the EFS file system. In your EC2 terminal session, run the following command to install the required utilities. Run the following command to create directory for mount. At the top of AWS Management Console, in the search box, search for choose EFS. Choose my first EFS file system. In Amazon EFS console on the top right corner, choose attach to open the Amazon EC2 mounts instruction. In the Amazon EFS console, in EC2 terminal session, copy and run the entire command in using the NFS client section. So under Amazon EFS console, choose attach to open the Amazon EC2 mount instruction. In your EC2 terminal session, copy and run the entire command using the NFS client. Okay, this one. Get full summary of the available and use disk space using this command. Notice the type and size of your mounted EFS file system. Type is NFS4 and size is 8.0E. So task 5 is examining the performance behavior of your new EFS file system. Examining the performance by using flexible I/O. Flexible I/O FIO is a synthetic I/O benchmarking utility for Linux. It is used to benchmark and test Linux I/O subsystems. During boot, FIO was automatically installed on your EC2 instance. Examine the write performance characteristics of your file system by entering this command. So next is monitoring performance by using Amazon CloudWatch. Let's go to CloudWatch. Let's go to all metrics. Choose EFS. Choose file system metric. Select a row that has the permitted throughput metric. Mhm. On the graph page, if you do not see the line graph, adjust the time and range of the graph down to 1 hour. There is no peak, but it says that there must be peak. Let's uncheck the permit throughput. Select the If you do not see data right input output bytes in the list of metrics, use the file system metric. On the statistics, select sum. On the period column, select 1 minute. Note that the peak value, which is around 6.7 GS. Take this number in bytes and divide it by the duration in seconds. The result give you the right throughput of your file system during test. The throughput that is available to a file system scales as a file system grows. All file systems deliver a consistent baseline performance of 50 MIBs per TIB of storage. Also, all file systems, regardless of size, can burst to 100 megabytes per second. File systems that are larger than 1 TB can burst to 100 MIBs per TIB of storage. As you add your data to your file system, the maximum throughput that is available to file system scales linearly and automatically with your storage. File system throughput is shared across all EC2 instances that are connected to a file system. For more information about performance characteristic of your EFS file system, see documentation link in the source section. So successfully we have completed this lab. Let's submit it for grading. So we got 15 out of 15. All the tasks are completed. Thank you.